when we're doing limits involving infinity, ideally you can do all the work in your head. I don't know if it's stupid to make a video, me explaining everything that's going on in my head, or maybe I should write more. Students in my class give me feedback. So I'm going to explain why we get each of these results. Maybe I'll end up writing a little bit more. But what we really don't want to do, back in pre-calculus, math 3 honors, whatever you want to call it, you memorized rules about exponents and in behavior. And those are true, but ideally we're explaining why those things are true. Okay, so let's look at number 1, the limit as x approaches infinity of two things, 5 and 2 over x squared. Well, the first part is easy. The limit as x approaches infinity of 5 is 5, because that's the constant line, y equals 5. The limit as x approaches infinity of 2 over x squared is 0. Because if we use inputs like a million, 2 over a million squared is almost 0. It's 0.000, 12 or 11 zeros before we get to the 2. 2 over a billion squared is even closer to 0. 2 over a trillion squared is even closer to 0. On number 2, when we do the limit as x approaches negative infinity of 3x minus 7 over 5x, well, that's going to be 3/5. Because if we use an input like negative a million, 3 times negative a million minus 7, we can just think of that as really close to negative 3 million. Divided by negative 5 million is positive 3/5, or at least close to it. When we use negative 1 billion, 3 times negative a billion minus 7, that 7 is less effective. So we can think of, well, that's really close to negative 3 billion, and that 7 does less percentage subtracting than when we subtracted 7 from negative 3 million. Anyways, about negative 3 billion over a negative 5 billion is even closer to positive 5/3. When we use negative a trillion, negative 3 trillion minus 7 is about negative 3 trillion. That negative 7 is less effective. Over 5 trillion is about negative 3 trillion over negative 5 trillion, even closer to 3/5. I'm assuming you look at number 3, limit as x approaches infinity of 2x minus 1 over x plus 1, and can guess that is 2. Hopefully you can explain that 2 million minus 1 is about 2 million over 1 million plus 1. About 2 million over about 1 million is close to 2. 2 billion minus 1 over a billion plus 1 is even closer to 2, because the minus 1 and plus 1 have less of an effect on a billion than they do on a million. 2 trillion minus 1 over 1 trillion plus 1 is even closer to 2, because the minus 1 on 2 trillion, the plus 1 on 1 trillion are less effective than they have been. I like the next sequence here. I don't know if you can see how these are related. 2x plus 5 over 3x squared plus 1, 2x with a bigger exponent on top, plus 5 over the same 3x squared plus 1, and then 2x cubed plus 5 over a same denominator. It's Friday afternoon, I'm pretty tired. Another 3x squared plus 1. Okay, so in the case of number 4, the limit as x approaches infinity, can we go bigger? Nope, we can't. 2x plus 5 over 3x squared plus 1. With numbers like a million, a billion, a trillion, we can kind of ignore the 5 and the 1. We can't cross them out. I'm just saying we can kind of ignore them. 2 million plus 5, we can ignore the 5. It's insignificant. 3 times a million squared plus 1. So what I'm imagining is, one of those millions, because it's like 2 times a million plus 5. And we're ignoring the 5. 3, oh no, that's not right. 2 times a million plus 5. In the denominator, that's when we have two versions of a million multiplied together. So we'll ignore the 1s in the 5. And then, we have about 2 million over 3 times a million times a million. So we have about 2 over 3 million, which is a very small number, 0.00000666666, whatever. So that's about 0. When we use a billion, again, we're kind of ignoring the 5 and the 1. So that's like 2 times a billion over 3 times a billion squared. One of the billions divides out, basically, and we get 2 over 3 times a billion. Same logic with a trillion. 5 and 1 are insignificant. 2 times a trillion over 3 times a trillion squared is 2 over 3 trillion or so. We get 0. The denominator is growing much faster than the numerator. In the case of number 5, 2x squared plus 5 over 3x squared plus 1. You know, the 5 and the 1 are always going to be ineffective. In all three cases, we're not going to cross them out. I am for effect, and then I'm going to erase it. We're ignoring those. With numbers like a million squared, a billion squared, and a trillion squared, adding 5, adding 1 really don't change what we have. So we're thinking 2 times a million squared over 3 times a million squared is about 2/3. 2 times about a billion squared over 3 times about a billion squared is about 2/3. 2 times a trillion squared over 3 times a trillion squared is about 2/3. Hopefully that works. So hopefully you can see when we look at the limit as x approaches infinity of 2x cubed plus 5 over 3x squared plus 1, you know, in number 4, the denominator overpowered the numerator. Here, the 2x cubed in the numerator is going to overpower the 3x squared in the denominator, and we're either going to say infinity or does not exist due to unbounded growth. And why is that the case? Well, again, with numbers like a million, a billion, a trillion, or things like that, adding 5, adding 1 don't really change the result. Just like, you know, if you won $1 million and then found an extra dollar, I think we're going to be talking about the million, not the plus 1. Okay. So when we look at 2 times a million cubed over 3 times a million squared, there's an extra multiplier of a million in the numerator. So maybe you can think of it as it's kind of like 2 times a million over 3. So that would be a very large number. Again, always ignore the 5 and the 1. They're insignificant for numbers like a billion. 2 times a billion cubed over 3 times a billion squared. We can ignore 2 of those billions factors, and we have about 2 billion over about 3 billion. Oh, over about 3, not 3 billion. Good gracious. That numerator is just growing out of control. Hopefully that makes sense. So when you see number 7, and I think I'm going to go home, the limit as x approaches infinity of 2x squared minus 4x over x plus 1. You know, is the numerator growing quicker? Is the denominator growing quicker? Or are they growing at about the same rate? Well, of course, the numerator is growing quicker. So we're just going to say, you know, a million, a billion, a trillion, 2 times a million squared overpowers negative 4 million. Negative 4 million is insignificant. Over a million is about 2 million over 1. It's not exactly that. Grab your calculator. It's pretty dang close. Anyways, 2 times a billion squared over a billion is about 2 billion, and 2 times a trillion squared over a trillion is about 2 trillion. This is also infinity or does not exist due to unbounded growth. Okay, maybe I will do number 8. Why is that here? You might think, oh, you're doing the same problem. Not really. This is the limit as x goes to negative infinity of that same 2x squared minus 4x over x plus 1. And, you know, when we use negative a million, the 2x squared... Uh-oh. Calculator problems. Computer problems. When we use a negative million, 2 times a million squared, negative a million squared is positive. No matter what, we ignore 4 million. Go back and erase. And then over negative 1 million gives us actually negative infinity. Because we're going to have a positive in the numerator, 2 times negative a million squared is positive 2 trillion. Over negative 1 million is a huge negative number, negative 2 million. 2 times negative a billion squared over negative a billion is negative 2 billion or so. Hopefully that helps.